dear students, once again welcome back for chemistry online class. Today we shall discuss about the physical properties of hydrogen chloride gas. For this you can refer to page number 149 in your textbook. Before I start this, I would like to recapitulate that we have done in the previous class. How can we prepare hydrogen chloride gas in the laboratory? Hydrogen chloride gas can be prepared in the laboratory by heating the mixture of sodium chloride and concentrated sulfuric acid less than 200 degrees Celsius. Explain why concentrated sulfuric acid is used for the preparation of hydrogen chloride gas, because concentrated sulfuric acid is a non-volatile acid. It means that it does not change into vapor. Explain why concentrated nitric acid is not used for the preparation of hydrogen chloride, because concentrated nitric acid is a volatile acid. It may volatilize along with hydrogen chloride. Now name the drying agent. Concentrated sulfuric acid is a drying agent. It is used as a drying agent for drying hydrogen chloride, because hydrogen chloride being acidic in nature, it does not react with concentrated sulfuric acid. Explain why other drying agents like phosphorescent pentoxide, quicklime are not used for drying hydrogen chloride, because hydrogen chloride being acidic in nature, it reacts with them. Now, temperature must be less than 200 degrees Celsius when we are preparing hydrogen chloride, because at higher temperature, a hard mass of sodium sulfate is formed, which is stick to the glass and difficult to remove. Now, state the method of the collection of hydrogen chloride gas. Hydrogen chloride gas is collected by the upward displacement of air, because it is heavier than air. And it is not collected over water, because it is highly soluble in water. Now, next, how can we identify the jar is completely filled with hydrogen chloride? It gives dense white fumes when a glass rod is dipped in ammonia solution brought near the mouth of the jar. Now let's move on to the today's topic here, physical properties of hydrogen chloride gas. First one here, appearance and odor. Hydrogen chloride is a colorless gas. It has a pungent choking odor. It is sour in taste. Now next here, density. The density of hydrogen chloride is 18.25 and that of air is 14.4. It means that hydrogen chloride is heavier than air. Now physiological nature. Hydrogen chloride gas is corrosive in nature. It irritates lungs, throat, nose, and causes blister on the skin. Now next here, liquefaction. Hydrogen chloride can be liquefied at pressure of 40 atmosphere, temperature of 10 degrees Celsius. Now solubility. Hydrogen chloride gas is highly soluble in water. Here, 1 volume of water can dissolve 452 volumes of hydrogen chloride. It means that hydrogen chloride gas is highly soluble in water. Now for this here, density. Here, to experiment number 1, to show that hydrogen chloride gas is heavier than air. We can show hydrogen chloride gas is heavier than air through a simple experiment. Take a jar with burning candle. Take another jar filled with hydrogen chloride gas. Then pour this hydrogen chloride gas into the jar which has burning candle. Now, what will we observe here? This burning candle gets extinguished because of hydrogen chloride. Here, hydrogen chloride pulls out or drives out all the air from this jar and occupy this space, which show that this hydrogen chloride gas is flow from this container to this lower container which has burning candle. And this experiment show that hydrogen chloride is heavier than air. That means we can pour the hydrogen chloride gas from one container to another container. As you can see here, hydrogen chloride gas is gas flows from this upper gas jar to lower jar, and this shows that hydrogen chloride gas is heavier than air. Now next, fountain experiment. This is very important. This fountain experiment can demonstrate the solubility of hydrogen chloride. That means hydrogen chloride gas is highly soluble in water. Here, to show that hydrogen chloride gas is highly soluble in water by fountain experiment. For this experiment, we need stand, drop containing water, jet tube, here rubber cork having 2 holes, drop cork, round bottom flask, clamp. Now first of all procedure here, a round bottom flask is filled with dry hydrogen chloride, and the mouth of this flask is fitted with rubber cork having 2 holes. One hole is fitted with jet tube. Another hole is fitted with dropper containing water. Then you have to set up this apparatus which are shown in the diagram, and the free end of this jet tube is completely dipped in a drop containing blue litmus solution. Now next step, when you squeeze or when you press the dropper containing water, here the water which is containing in dropper is entered into the flask, and this flask is filled with dry hydrogen chloride, and this hydrogen chloride readily dissolves in water and forms hydrochloric acid. And this, when you switch it or press this dropper, it creates partial vacuum. That means outside pressure being higher than the inside pressure. This outside pressure pushes this blue litmus solution into this flask, thereby forming red fountain because of this hydrochloric acid. The hydrogen chloride which was present in the round bottom flask readily dissolved in water and forms hydrochloric acid, as a result thereby forming red fountain. You know, acid they turn blue litmus solution of paper red. This is how we can show that through this fountain experiment, hydrogen chloride gas is highly soluble in water. Dear children, here we have come to the end of today's online class. Thank you very much.